wait.
Even number of
Sorry. Okay, like this. Yeah, there's 4, right? So 16, so I can factor out an x and a 4.
And then what's left over?
8x cubed plus 7.
Yeah.
All right.
And then
It's simplified.
Let's take a look at these. Who's got 1A's answer? What do you think? Anybody got 1A? Yes, sir.
2 over 11.
2 over 11. Anybody else got something different?
I get 2 over 11.
All right, hey. All right, consensus. All right, let's find out. So I like to do, you got a couple things going on here. It's really unfortunate that, when I see that, I know the operation between those is multiplication. We've been taught that. The one situation that's not true is when you have something like this. There's understood to be what between those things? Who knows? Addition. 3 and 1/5. That's really what that means. We weren't around when they decided how to rewrite that, so we could have said, hey, that looks like multiplication. So this is not 3/5. This is 3 and 1/5. How many knows what? Okay, all right. So, who knows the shortcut to changing this into, like, improper? Yeah, so 5 times 3 plus 1. Why the hell does that work? Because how would you do this? How would you add those? What's currently under the 3? 1. So we have to do to this. Multiply by 5, right? 5 times 3, 5 times 3. And then you would add it to the 1, add it to the 1. That's why the shortcut works. Right? So 5 times 3 is 15, plus 1 is 16. This, for example. Cool. So part of this problem is I gave you mixed numbers. You want to change them to improper fractions. Improper meaning the top is heavy. Right? So inside here, you don't have to do that. There are other ways. You could borrow from the 3, but that sort of sucks. So let's not do that shit. Let's change it to like we just did. 16/5 minus, what would this be? 29/10. I love it. Come on, Jeff. First day, you can write kind of well. And then let's just leave that guy out there. Because what is order operations? What's the order operations? Yeah, please excuse my dumb ass son. Darren's son. Real quick word about this. This is an unfortunate way to write this because it could have been this. Totally all day long could have been that. Which one's easier to say? PEMDAS. What's the other one? PEMDAS. You sound like you're drunk, right? No, it's PEMDAS. No. Yeah. So, and the reason this is true is because you don't do multiplication before division. You do these as they come. So that's why it could have been written like that. So the correct way to write this is definitely parentheses first. Definitely exponent second. Either one of these as they come. Either one of these as they come. That's the correct way to write PEMDAS. That's what order operations. And what are order operations? They're math grammar is what they are. How do you parse a sentence out? So there's a lot of similarities between math and English. Somebody is like, no, don't do that shit. Don't put English in my math. Don't put math in my English. This is not candy bars. All right. So what do I do from here?
Multiply them.
Yeah, I got to get LCD. I like it. So it'll be 32 over 10 minus 29 over 10. What can I do with this division of a fraction? I can make that into multiply by the reciprocal. I like it. And so what is 32 tenths minus 29 tenths?
3 over 10.
3 over 10. I like it. So I get 3 tenths times 20 over 33. What can I do there?
Cross cancel.
I love it. You don't want to multiply first and then reduce. It's so much easier to make your numbers smaller first and then multiply. So 3 goes into 33, 11. 10 goes into 20 twice. So I get 1 times 2 is 2. 1 times 11 is 11. That's amazing, Jeff. Good. So the crowdsourcing worked on that. I like it. 2 over 11 is the right answer. Yeah. So if you made a mistake, identify what the mistake was and make sure you understand why it was a mistake. Any questions on that first one? Okay. Fine. Glad I have multiple copies of this. Next one. This is a pure PEMDAS problem. Right? The more uncertain you are, the less you should do at once. So I always kind of try to do as many steps as I can. You don't have to show every single step, but you have to show enough. I have a shirt that says, show your work. I'm going to wear that every now and again. It's kind of important to me. I can't help you unless you show me your work. Yeah?
So when something happens inside a parenthesis, when does it go away? Like, for example, that -5 stuck next to it,
Yes.
and you add that, and that's the -1 and the -2 equal to a -3. And then your exponents are next. So that would be,
I like it.
and then would that -5 still be stuck next to parentheses?
Exactly. I mean, why are those parentheses there? For a couple
When did they
reasons.
disappear?
They disappear when the reason they're there is no longer true. So I'm going to point that out as we do this. So there's two kind of reasons. One is so that you cube whatever -1 minus 2 is. If they weren't there, the 3 would just be on the 2, and that's not right. I want to cube the whole damn thing. Secondly, the whole damn thing is being multiplied by 5. That's the last reason. So the minute you multiply by 5, they're gone. You don't need them anymore, because that's the real reason they're there. That's a really good question. That's parentheses bug us like that. So like Nathan just said, you do inside, that's the P, that's the please. Excuse my grammar, that's the P. So inside there you get -3, like you said. The big mistake is people make that 27. That's a mistake. Let me show you real quick what I'm talking about. So let me just focus on that kind of thing. Divided 4 divided by 2 times 8. What's 4 divided by 2? 2. And this is saying, take that and multiply by 8. It would be unfair to say that this is 4 divided by 16. What's the only thing being divided in this statement? 2. So how the hell did it become 16? How would you rewrite 4 divided by 2? What's another way to write that? 4 over 2. Times 8. The 8 is up top. How would it get down to make the whole bottom 16? That's not fair. Poor little 4 dude should be divided by 16. Shit. You guys understand? This is why math grammar is important. So everybody comes out with the same answer. Right? Or else you get shit like things exploding on Mars. Right? Well, we thought it was 7. Well, we thought it was 18. No shit. I don't know if you guys know that story. That actually sort of happened. They used the wrong units. One team used the wrong units. They sent this $1 billion thing up and it smashed into Mars. Oops, sorry. Like, oh crap. Anyway, so this, you do not divide last. You just don't divide last unless it is the last thing. I don't know if that makes sense. I see a lot of people dividing last. No, don't divide last. So this is divided by 9 times 3 minus 2. So what's the next thing I could do?
In the exponents.
Good, exponents. So this is 3 minus 5 times
-27.
-27. Divided by 9 times 3 minus 2. Good Lord. What's the last things I'm going to do in that, what it looks like now? What's the last? Yeah, the 3 minus and the minus 2. I'm going to do those last because those are part of AS. It's the end of PEMDAS. That's the ass of PEMDAS. I love that. Never said it before. No? It's just for me. Okay. That's I like it. I like that joke. So the next thing I'm going to do, this is last and this is last. So in here, what comes first? Yeah, whatever comes first. You do it as it comes. When you're at the MD level, you do it as it comes. So what's -5 times -27?
135.
135. -5 to -20, positive 135, right? And then what's 135 divided by 9? 15? And now I got 3 plus something minus 2. What's the something? 45. 3 plus 45 minus 2. 46. Kick ass. How you doing? No? No good? And let me say something real quick in general. Math 110 is one of those classes where there are people in here who haven't taken math in like 5 years. You don't have to raise your hand. But there are people in here. There are people that just took math. There are people that just barely missed placing out of this, so you know your shit, and you're like, why am I here? And you only have a couple things you're not sure about. There are people in here that are like, should I be here? Oh shit. So do not give anybody else any flack about them not knowing something. Just shut your mouth and enjoy that you know it. That's great. So please, if you have a question, at least 8 other people have the same question. Ask it. Don't somebody else go, "Well, you asked that, you should shut up." You let them ask their question. You guys with me? If you understand it, great. Sit there and enjoy it. Don't screw somebody else up. Jeez. All right. All right, so any questions on that one? We're going to take a break as soon as we're done looking through this, okay? Just to give you a little light at the end of the tunnel. This one, the mistake people make, the instructions say simplify. Simplify means multiply, whatever it means, multiplying, add, subtract, do the operation. So if you try to factor this, you're going backwards. Because what does factor mean? Undo multiplication. If I said factor 16, you would say like 8 times, you just undid the multiplication, right? So factoring and simplify are opposites. So when I say simplify, that means multiply. Don't try to break it apart, put them together. So here I've got to do what? How do I multiply it?
Foil.
Yeah, extended foil. I love it. And if you've taken me before, you know this. If you know foil and you love foil, I am not crapping on foil. Keep going, foil. That was a weird phrase. We'll get over it. Foil is fine, but it's so unnecessary. It is so unnecessary. I don't like us making mnemonic devices we don't even need. It's just, how many things do I have to distribute? Like the 2x has to go to everybody? And the 3 has to go. Why do you need a mnemonic device for that? You don't need it. It's just distribution of everything that's there. That's all it is. So if you know foil, you love foil, I'm not saying not use foil, but what would this be? This isn't foil. This is, you got a first, a middle, a last. The M's would be in there. What kind of word is that? All right, I'll stop. So the 2x gets a turn. What do you get there?
8x cubed
8x cubed.
minus 12x
Good. 2x times that minus 12x squared.
plus 18x.
All right. Class spokesman is going for it. And then
12x squared.
yeah, 12x squared. So look, what I'm going to do is I'm going to line up my like terms. You don't have to do that, but what the hell. And then 3 goes to negative 6x.
Minus 18x.
And then 3 goes to 9.
27.
And the reason I put this kind of problem down here is, number 1, so you remember how to distribute correctly. Number 2, so you remember why cubes factor the way they do. Look at all this shit dying. Right? Because I don't know if you remember how to factor a cube. You're going to find out in a minute, but the way I teach it is there's a little dude and a big dude. So here I get, what do I get again? 8x cubed
Plus 27.
plus 27. 8x cubed is 2x times 2x times 2x. So there's 2x, and there's the other 2 2x's. 27 is 3 times 3 times 3. So there's 3, and there's the other 2 3's. So I don't know if you remember cubes. We'll find out. But that's set up so that it's going to have a lot of stuff cancel. When I teach this, I talk about that middle term as being like the guy on Pulp Fiction, the cleanup guy. Remember the poor guy in the back of the... Anybody never seen Pulp Fiction? There's a guy in the back of the seat and something unfortunate happens when they hit a bump. Let's leave it at that. And we got to call the guy, was it the wolf?
Yep.
You got to call the cleanup guy. So this is the cleanup guy. This is the guy that makes these opposites so that it kills the shit you don't want. Right? Or gets rid of things that are already dead. I don't know. Alright, so that's kind of morbid. No one. Alright, how are we doing? Is everybody cool with that? Okay, maybe. Alright, so what about this guy? What the hell's going on here? What's the very last thing I'm going to do here? That.
Yeah.
Because I'm going to do in the parentheses first if I follow. Now, some of my colleagues disagree with me, but it would be so much easier to simplify the inside so I got less stuff to do the negative 2 to. If you were shown a different way, trust me on this. You've got to understand this. There are multiple ways to do the problems we do. I'm not telling you have to do it the way that I happen to do it, but I just have to see the work so I understand what you're doing. Is everybody with me? Sort of? Alright, so if you don't like the way I'm doing it, there are other ways to do it. You don't have to do it the way I'm doing it. In fact, that's part of what math is making it your own. Doing it your way, as long as it's legal. So I don't have to worry about this negative 2 till the end. What can I do on the inside?
Move the negative to the opposite.
Good, I like it. Anything to a negative power. What's a negative power mean?
Move to the opposite side.
Flip. So x to the negative 2 would become 1 over x squared, for example. So what's the only stuff in there that wants to move? Yeah, the a to the negative 6 and the b to the negative. That's the only two things that are being raised to a negative power. So they're the only things that are going to move. Okay, so a to the negative 6 is like owing 6 a's. Like 1 over a to the 6 is like owing 6 a's. They both mean the same thing. So I can, well, real quick, what's 24 over 40 reduced to?
3 over 5.
I like it. 8 goes into both, 3 over 5. These 6 a's go down. There's already 7 down there. See those 6 a's? They went down. Bam. Those 7 b's, they go up. And what's already up there? 7 other b's. Oh, freaking big old collection of b's up there. Let me stop there for a second. So all we did was 24 over 40 reduces to 3 over 5. Ooh. Right, so do the numbers, get those out of the way. What wants to flip? Anything to a negative power. It's the 6 a's. The 6 a's flipped down, and the 7 b's flipped up. And real quick, the real property is when you divide, what do you do with powers? Who remembers? When you multiply, like what's x squared times x to the third? X to the... Right, because what do you do with powers when you multiply? You add them. Because I got 2 x's in a row times 3 x's in a row is 5 x's in a row. Ooh, don't let that be a big deal. It's like, wow, that's amazing. Good job. You guys kind of with me? So properties of powers are remarkably simple. They just get a little weird when you start throwing negatives in there, like everything does. So like the b's. What's 7 minus negative 7? It's because you subtract when you divide. 7 minus negative 7 is 7 plus 7 is 14. Well, what am I going to get? I'm going to freaking 14. So if you flip shit, you get rid of the negatives. And what's the big places that screw us? Negatives and 0. Right? So if I can get rid of negatives, yeah. You kind of with me a little bit? And again, this is only one way to do this. If you'd rather not flip them and do like I just did, 7 minus negative 7 is 40, beautiful. No problem with that. Completely legal. I love it. This is just a suggestion. So inside I get 3b to the 14 over 5a to the 13. And what's this mean? What's the negative mean? I got to flip it, and I also have to
add a 1.
Change the sign.
Change the sign. Yeah.
Negative means flip. The 2 means square. That's it. Negative powers only mean flip. That's all they can do. They can't change the sign of something. They can just take whatever it is and turn it over.
So what's inside the parentheses?
Good. So the first thing I would do is flip everything.
Okay.
What do I still have to do?
Square.
Square. I haven't squared it yet. So I look at this power as 2 things. Flip it. Okay. Square it. Oh shit. Okay, let me do that. Oh, does that make sense? And again, if there's a totally different way that you do this that you like better, great. Just make sure I can see what you're doing. So when I square these, I get 25, a to the
169.
oh shit. Alright. You guys ready? You guys ready? This is where you guys think that I'm off my meds. There's no 13 in here anywhere. There's no 13 in there anywhere. So you guys are, yeah. No, what does that 13 mean? There's 13 A's. There's no 13. There's no number 13. So if I square that, I have 2 A13s. What's A13 times A13? A to the 26. So you multiply powers when you raise something with a power to a power. There is no 13 to become 169. It's not 13 times 13. It's A13 times A13, which is A26. Do you guys see that? So it's not... I really want this to make sense. I'm sorry. So if I have 8 to the third power, how would you work that out?
8 times 8 times 8.
Good. 8 times 8 times 8.
4 times 8 equals 512.
512. I love it. Now real quick, now watch. The reason that powers and numbers don't work the same is because if I wrote numbers with powers, they would work the same. So what do I mean by that? What's 8 is 2 to the what power is 8? 2 to the third power is 8. So what would I do with these? Multiply. So I get 2 to the 9th. What's 2 to the 9th? 512. So the properties work as long as they're written in the right format. So if they're not written with a power, I'm just going to take 8 times 8 times 8. But if they are written as a power, I just multiply the powers. It's a whole other way I can do this. But that's why variables and numbers work differently, because they're not written in the same format. That's it. If I do write them in the same format, guess what? They work the same damn way. They have to. Because what are variables? What are variables?
Numbers.
There you go. That's the key word. They're numbers. We don't know yet. So how do they have to act? Like any other freaking number does. They have to. Maybe. Some of you guys are like, dude, what the hell are you saying? But please understand, everything we do with variables, believe it or not, is exactly the same thing we do with numbers. You guys don't believe me? I don't blame you too much. It looks a little different. Where am I? Oh, so this is going to be 26. On the bottom, what am I going to get?
28.
Yeah. So 9,
Sorry.
b to the 28. Yes. Because 2 groups of 14 B's is 28 B's. That only makes sense, right?
I wanted to know, like, so depending if it's negative on the A, -6, that's when you bring it to
Exactly. I love it.
So
Is the
what is
24
the-
being raised to negative power? No, it's next to something. So that's why the 24 stayed up top and that became a 3 when we reduced it, right?
Yeah.
24 is not going to go down because it's 24 to the positive understood 1. This has no reason to go down. Another way to look at it, that guy's unhappy. If I take him now, he's happy now. It's another kind of silly way to look at it, but oh well. Maybe. Math has to make sense. It has to. Or else we all go back to caves and go, shit, we'll try this again. Alright. I know. Math people, we say that kind of thing all the time. Because it's true. Now, what's something raised to a 0 power? Beautiful. Why?
Because you can't multiply by 0. It's just 1.
Because now watch. What's understood to be in front of the x?
1.
1. So if I have 1 times x, that's 1x. So if I write 1 and I don't put any x's next to it, so how many x's do I have?
None.
There's just the 1 that's sitting there, right? That's one way to see that x to the 0 means 1, because it would just be left with that understood 1. There are no x's. So what is there? The 1. A slightly different way. 5x squared, what do I divide it by to get x to the 0? What do you do when you divide? What do you do with powers? Subtract. So what am I going to put on the bottom so it ends up to be 0?
-2. X to -2.
You're thinking a little too much. X squared, because you're going to subtract. 2 minus 2 is 0. Is that cool? You guys kind of with me? No? So when you divide, you know you subtract powers. So 2 minus 2 is 0. But what is x squared divided by x squared? Oh, yeah, there you go. Done. All right. Anything to the 0 power is 1. Because it acts like 1. What's x to the 0 times x to the 7th? What do you do with the powers? No. Add them. What's 0 plus 7?
7.
What's the only thing I can multiply by and it keeps it the same? What's the only number I can multiply by that doesn't change it? 1. So the x to 0 must be 1. Because what did it do to the x to the 7th? Nothing. You guys, stay with me now. I don't know, something I can't read already. I always tell my students I don't want to play poker with you. And I'm like, holy shit, I got all my... Can't play poker. Okay, so coming back to this problem here. 3 to the 0 is 1. Minus. Well, now what's being raised to the 0 power over here? This. So I get 1 minus 2 times
0.
What's negative 2 to the 0? 1. Anything to the 0 power is 1. But it has to be raised to the 0 power. Is this 2 being raised to the 0 power? No, so it's still 2. And what's 1 minus 2? Negative 1. Alright, maybe. So this is what I was saying earlier. Variables have to act like numbers. Why am I allowed to go ahead and add these two together? Because they already have LCD. So they have to, if they didn't, I have to make the LCD the same way I do with numbers. So here I can just add these. What do you get when you add them? X minus X is 2X plus 2. Now if you stop there, you're not quite right, because whenever you have fractions, what's the last thing you got to check? See if it reduces. Yeah, so what comes out of the top? 2. So what's kind of funky about this is no matter what you make X, except for one thing, what can X not be?
-1.
Beautiful, because that would make this undefined. Any other X value you choose, this becomes 2. So if you tried square root of 11, if you plug it in this, the answer is 2. That is kind of neat. Doesn't matter what X is, it's always 2, except if X is -1, and then the whole thing freaks out. You guys understand it? All right, I've fried your brains already. We're almost to the break. Keep it going here. All right, 2A should have been easy. I feel completely comfortable saying that. You should not have had any troubles with 2A. So you're like, shut up. But just to be honest, this is your bread and butter. This is what you desperately have to come in here with. Solving equations. Oh my God, that's the bread and butter. So what do you have to do, of course, first? Distribute. Everywhere you see something, what are you distributing here? -3. So here you get 2X minus 2 minus 3X
plus 12.
That's the most common mistake, is to not make that a plus 12. Equals
3x plus 4x.
2x plus
Oh, okay.
2x plus 4. 3x minus x is 2x. Just putting your like terms together. Now the other side I can put my like terms together, right? Bread and butter. 2x minus 3x. Negative x. Negative 2 plus 12. Positive 10. We're almost there. Yes, ma'am.
From here, I did 2 different ways. I put them all on the other side so you have the 0. But then I also did the equation where to solve x. So I wasn't sure if you wanted
Gotcha. So the only time we have to make it equal to 0 is if there's a power higher than 1 on my x's, because then I can't put all of my x's together. Here I can get all my x's together on one side, all my numbers on the other side. But like this last problem, can I put my x's together? No, they're not like terms. So then I have to make it equal to 0, which I was nice and already made it equal to 0. You kind of with me? So it's overkill to make this equal to 0. Where to go? There it is, Jeff. So which way do you want to go with this? All right, sure. Subtract 2x. And I get negative 3x plus 10 equals 4. Minus 10. Negative 3x equals negative 6. Divide by negative 3. X equals 2. Cool. Sorry. Is there equal to that? The most common mistake I see there is people just write a 14 out of nowhere. Where did the 14 come from? Where did the 14 come from? They put 10 and 4 together. How did they get together? They're on opposite sides of the Grand Canyon there. So you got to transport them over by changing a sign, right? I mean, you see what I'm saying? I mean, that's a really easy mistake to not make. Okay. All right. What about part B? What makes part B worse? Yes, you need an LCD, but the nice thing is, this is one situation where the fractions can be killed or canceled, if you prefer less violent math.
LCD 12.
LCD is 12, so what's this guy need?
4.
This guy needs
2.
times 2. So now they all have a 12.
Yeah.
So it's got 2 sides, so I'm allowed to multiply by 12.
Cancel.
So that cancels all the bottom, so what am I left with?
8x
8x minus 10
equals x plus
x plus 7. Alright, let me stop there for a second. Now some of you guys might have slightly different ways of doing that problem, but they all should come out to this step eventually. And now this is just like the last problem. You move the x's to one side, numbers to the other side. So subtract x, 7x, add 10, equals 17. Divide by 7, so you get x equals 17 over 7. And this is not the place anymore to go, man, I must be wrong. You're going to get ugly answers, right? We're getting closer to real life. ever closer to real life with the higher you go in math. So your answers could be disgusting because that's real life. Disgusting. 417 over 7. What did it do to you? Alright, now please, dear God, please ask a question on something if it doesn't make sense, if you're not sure what's going on. Because if you feel that way, at least 8 other people feel the same way. Completely made up number, but it's roughly right. Alright. So part C we talked about earlier about it's equal to 0, which is what I need to do when my x's are not like terms. But then what do I do once I get that? What do I do with the x squared minus 3x blah blah blah?
You should count the two numbers. The term became 18.
Kick ass.
And the plus became negative 2.
I like it. So you're factoring this bad boy, right? Because the whole idea is if I have two numbers that multiply by 0, one of them has to be 0. If I have two numbers that multiply by 4, what could the two numbers be? 2 and 2, 4 and 1, 8 and 1/2, 400 and 1 over 100. There's an infinite number of things they could be. Oh shit, that's why it's got to be equal to 0, because then you know one of them has to be 0. You guys understand? So you don't want to make that other side anything other than 0. If it's not 0, make it that way. If the powers are higher than 1 on the x somewhere.
I'm confused. What happened to the 12s at the bottom?
Oh,
Oh, thank you. I was confused too.
okay, good. All right. So let's go back for a second. All right. You ready? So you're cool with what we did first, right?
Yeah.
Now all the bottoms are 12. I can multiply both sides of an equation by anything I want to except 0. You can never multiply both sides by 0 because then everything in the universe would be 0 equals 0. Alright, they all be living in caves, all that kind of shit. Alright. So what is everything being divided by now? 12. So what's a smart number to multiply both sides by? 12, because then all the 12s will cancel. So really what happened is